We are continuing the
Um,
test.
Where's for the new book? Do you know the pages for the new book?
Oh, for the new book, I am on page 359, question 41.
Awesome.
That's the 22-23 version.
Are we doing like what are we doing again? Like the 5 and then check, or how are we gonna do it? 5 questions?
Yeah, we're gonna do the 5 questions and then check. If you go ahead, I will not hold it against you,
Don't
but
go ahead. Yeah, don't go ahead, Jade.
I'm thinking I might be on the wrong test. For the old book, what would that page be?
49.
489? 489, they say.
Okay, thank you.
All right. We've got about 50 minutes. Let's see if we can at least get to the end of the test. I wanted to go back to the beginning and do those first 9 as a palate cleanser afterwards to make you feel better about yourselves again. And
Do you think we're not gonna get to the end of the test?
oh, we will definitely get to the end of the test.
Oh yeah.
So
We don't have to.
let's go ahead and begin.
Play a game.
and stop. All right. How did you fare? Was it flying?
No, I got 3. Got through 3.
All right. So, 41. If I have to admit to an Achilles heel, I have to admit statistics and probability is the one that I am least confident on. It's one that gets shoved in the background of teaching a lot. They're all about, oh, we have to hit this and this and this and this, and then the stats and probability gets thrown on at the end if we have time. So, do you guys know how to find an expected value?
I probably do, but I just couldn't think
Okay.
of it.
So, what's going to happen is that you're going to take that occupancy rate, in this case it's 0.6, and you're multiplying it by the probability of that thing. And so expected value is about the value times the probability, in this case 0.2. And we're going to add all of those up. You take the next probability times the next value, the next probability times the next value, and you add all of them together. And that is the rate. And then you have to multiply it by the number that you actually have. And so we're going to take the 0.6 times 0.2, 0.7 times 40, or 0.4, 0.8 times 0.3, all of those together. And I want to make sure I'm saying this right. Terrified I'm going to mess it up. And so you add all of those together and you should be getting a decimal. What decimal do you get? Okay. So this is that expected value. And then we have to multiply it by how many rooms we have. So this is the percent. And we just have to take that percent of the possible rooms. So how many rooms were possible? 80. So you take the 0.73 times 80. And that will tell you how many rooms it would be. So the real question is, for those of you who said, I got this, was this the problem that you got, or did you waste too much time on this problem when you should have moved on to something that you would have been able to do better?
Wasted my time on this.
Yeah, so again, the whole point of this timing practice is to help you learn to cut your losses. Take a guess at random, but don't spend forever on this one, particularly if it's something you're not confident about, because it's like, I'm trying to see if I can get a number that matches what they've got, but I don't know if I'm doing it right anyway. Don't give it too much time if you are truly lost. You can come back later. Come back at the end, absolutely, but don't miss 3 problems that you know how to do on one that you are really not confident about. So, here. I need to mark my answers better. I just had it. So, our answers for the next 5 would be C, F, D, and then back to F, and back to C. It's a palindrome. Isn't that nice? So let's look at the next ones. Matrix product. First of all, I'm going to ask, what size should our answer be?
3 by 3.
3 by 3. We know at least that much, so that narrows our answer possibilities to 2. Next up, pick an element that's different between the two of them. I'm gonna go for the first row, second column. If I take the first row, I have A. The second column is 0. What's A times 0? So which one of those matrices do I want? F. So again, know what your answer's supposed to look like. Find an element to test that's not the same. Say, yes, that's the way it's supposed to be. Process of elimination, do not try and do all 9 of those elements. Not worth your time. All right, 43. Geometry. What are we going to be using?
You add them equal to 180.
They add them and equal to 180. It's a straight line. It's a linear pair. All of those things, it's going to be equal to 180. Straight lines are 180, just like full things around are 360. If you do a 180, you completely turn around and go the other direction. Anything to help that set in your brain. Once you know that, it gets really easy. If you don't know that, it's really hard. All right. 44. This one actually shows up on ACT tests fairly frequently. How did you do this one? I'm curious in your brain patterns.
I plugged in numbers.
You plugged in numbers. Plugging in numbers is a great way to do this problem. And it does show up fairly frequently. So the idea is that we have this A equal to 2B plus 3C and then minus 5. And then they tell us the value, what happens to the value of A if B decreases by 1 and C increases by 2. So, if B decreases by 1, what happens to that 1? Gets multiplied by 2. And so this is actually going to decrease by 2. And then this one, if it increases by 1, it's going to increase by 3. Because that's the change. 1 times 3, negative 1 times 2. Combined together, increases by 1. Plugging in numbers is great, but that's what's going on in the background. If you are plugging in numbers, pick really easy numbers, like 0. Well, if I have 0 and I have 0, A equals negative 5. If this decreases by 1, I have negative 1 times 2. If this increases by 1, I have plus 3 times 1. And then the minus 5 hangs out. And then comparing these two, I'm going to have negative 2 plus 3 minus 2, or minus 5. 3 minus 7, I get negative 4. It's increased by 1. Yes?
So I'm confused though, because would the answer be H for this one, or the answer be F?
It says C
Well, C was
increases by
increased
2.
yeah.
She has it as it
Oh,
increased by 1.
yeah. Okay.
Did I mess up somewhere?
No, you got it right. I was kind of lost in how you would get it.
You just have C increasing by 1, but it
The
increases by
problem
2.
increases by 2.
Now I'm all confused. It says the increases by 4. What did I do wrong?
You have C increasing
the
by
value
1.
of C increases by 2 and not 1.
Oh. Okay.
It would be negative 2 and 6.
Yeah.
My fault.
3 plus 4.
It happens.
Makes sense.
I'm really sorry. I hate teaching you guys wrong. The real question is, have you figured it out? Because I'm the one that you were confusing.
Yeah.
Okay.
I figured it out. I'm good.
Oh, my fault. I apologize.
And then also on 43,
You want to go back?
yeah, we go back. real
Okay.
quick.
So, again, it's possible that the answers in the book are wrong, but they aren't usually. So we know it equals 180 for a straight line, right? And we have 4x plus 6 is one angle, and we have 2x is the other angle. So in terms of variables, we need to combine those together to get the whole thing. 4x plus 6 plus 2x is going to be 6x plus 6 equals 180. Good so far? Subtracting 6 from both sides, I'd be tempted to factor out the 6, but anyway, subtracting 6 from both sides, we get 174 is equal to 6x. If we divide both sides by 6, what do we get?
29.
29.
Which is answer C.
Double
Yeah, but
it.
then you plug in 29 to the.
So
That's where you're wrong.
it asks for the
29.
smaller of the two angles. And so it's that trickiness of you got the right answer, you did the math, but you have to make sure you're answering the question that they ask. And this is one of those things where I argue with ACT, because at that point they are not checking your math, they are checking your detail orientedness. Are you answering the question that they asked for? And they serve up that wrong answer on a silver platter of multiple choice because people do. And on some cases I'm fine with the wrong answer if it's, if you make this common math mistake, you would get to this wrong answer. In this case, it's just them being annoying. But it is, and we've got to learn to fight it. All right, and then last 45, it's a slog, but it's not bad. How did you tackle this one?
I didn't.
Oh, you guys didn't get to time for this one? Well, we have the time. I'm going to just reassign it. There's no point in me going over it if you haven't had a chance to tackle it. So let's start. We know that the answer's C, but give it a try. Can you find it? Can you work through it? We will take 5 minutes and go from 45 to 49. You may begin. just over halfway. Oh, sorry. Time got away from me. I apologize. So, how did that one feel now that you had time to tackle it? It's a fairly simple proportion. You just need to make sure that you are setting it up properly. And so this X gallons, if there are 128 fluid ounces for every 1 gallon, there's going to be, oh, how do I want to do that? I think I'd solve for fluid ounces and then convert back to gallons, and so I'd be saying 128 X fluid ounces. And then half an acre, there 1 acre is that 43560, and I'd cut that in half for the acre, and then it's a cross multiply problem, would be how I'd tackle that. I'm not sure that that's necessarily faster or slower than some methods that you might have picked, but that's how I would tackle that one. Oh, and I'm forgetting to move. I'm not sure I like this clock thing. Yeah.
I think he was only using it because we were doing a practice test.
Ah, so maybe I'll move the clock somewhere else. So that's how I'd tackle that one. The answer would have been, making sure I have this right, J. So yay, nay, maybe. Okay. For the next one, this one is a classic ACT problem. How many of you have seen this problem before on a different test?
Which one?
The table 1, 46. The capacity and the booths and that sort of thing. It shows
Yes.
up fairly frequently. The answer would have been
You put it
D.
on the board.
Oh, okay, I'm losing track. It's J. Yeah. So we have C, we already talked about. J is the next one. Resetting brain. All right. So, probability, independent events.
We didn't go over it though. You just put the answer on the board.
Yeah. Do you have questions on how to do 46? That one in general, like I said, that one's a classic ACT problem. It shows up a lot. All right. 48. Let's 47. Okay, give me 2 seconds. Better. Hey, it works. Try it on a test. If you get yourself into that spinny mode, reset your brain. Because the instant you start feeling, I'm panicked, it gets worse. So we are going to be talking about 47. The answer to 47 is D. Making sure my brain is right. This one's the probability one. So, the key to this one more than anything else is that word independent events. So, if they are independent events, all we just have to do is multiply the probability of one times the probability of the second one. If they are connected in some way, that is when you would get to the E option and you take the probability of the two events and then you have to subtract the overlap. So for this one, independent events, very simple, multiply one times another one. That's the classic drawing something out of a bag and spinning a spinner. You just multiply the two probabilities together. Good on that one? Okay. Next one, we've got a masquerading sine, cosine, tangent problem. 48, the answer should be J. Questions on where that one is coming from?
Can you just show how you did it? Because I was all over the place.
Okay, so we have a standard XY coordinate plane below. An angle is shown whose vertex is passing through the origin. So we're starting here, and it's going to the coordinate positive 4, negative 3. 1, 2, 3, 4, 1, 2, 3. And so we are looking at this angle, but for the sake of triangle, we can work with this angle. And that's the key to it. Again, we have 4 and 3. What's our third number going to be? 5. We have 4 here, we have negative 3 here, we've got 5 for our hypotenuse. Pythagorean triple strikes again. So, what is the cosine of theta? And that's our angle here. Is cosine going to be our x coordinate or our y coordinate?
X.
Yeah. And so our cosine is just 4 over 5.
How do you, like, what's the rule that those angles, you can do that? Like, the outside angle is the same as the inside one.
That's just the rule.
It's just a rule.
It really is that easy. We're talking about the cosine, and so it's the x over the hypotenuse, but the angles go both ways. You did it with the unit circle a little bit, kind of in the sense of you could have this angle, or you could have a negative angle that way, and it was still where you ended up. So it's that sort of thing. Whether you're going around the outside or in the inside, it's your landing spot that determines your answer. It doesn't care which direction you went. And again, you do that mostly with the unit circle, and so the fact that this is bigger than 1 kind of throws you. But remember, a unit circle is going on over here, and it doesn't matter, it's still the same angle. Good question. All right, and then our final one, answer to 49, would be A. And from the exclamations, we should talk about this one.
C.
No problem. So, what we have is which of the following expressions for any are equal to all real numbers x? So, we have negative So, sorry. I said equal to all real numbers. That are equal for all real numbers. So, whether this is a positive or a negative number, this negative sign will change it, but it gets kind of washed out or erased. It's always going to go positive when we square it. And then when you take the square root of a positive number, it equals the positive number. Or in other words, the absolute value of x. Absolute value of x is always going to equal a positive number, the absolute value of x. This is always going to equal a negative. Whether you start with a negative or you start with a positive, this will make it positive, which means this always makes it negative. These two are equal to each other. The third one is always not.
The second one, the negative's on the inside. I mean, it doesn't change
Oh,
anything.
yeah.
But
So miscopy on my fault. But the idea is, no matter what you have, if you square and square root it, it goes positive. No matter what you have, if you add a negative sign in front of it or not, absolute value makes it positive. Here, it is positive. It will always go negative. I would check a number like 5, something that is fairly easy to check. Put a negative in front of it, you have negative 5, square it, you have positive 25, square root of positive 25, we're back to 5. 5, throw a negative in front of it, we have positive 5, absolute value, still 5. 5, take the absolute value, it's still 5, throw a negative in front of it, we have negative 5. And so, if you need to check a number, please check a number. But that's the theory that's going on, that's a test case.
For the first part, when you take a square root of a number, doesn't it become plus or minus?
No, that's a definitional thing. So, if you have the square root of anything, this will equal a positive number. If you have x squared equals that number, when you take a square root, that's when you have to consider the positive or negative. If they have the square root already written out, it's definitionally positive. If you take the square root, you consider plus or minus. Very good clarification. Right.
and I'm going with a C+.
We will go forward. All right, starting with 50.
We won't get there.
We're gonna go ahead and go 10 minutes till the end and see where we get, because we are almost out of time. So, 10 minutes. mind second guessing. We're only going to 55 because I think that we're going to need enough explanations. It's better to get explanations than answers in. So I've given you 6 problems. We'll go ahead and go till 6 minutes. And stop. So for question 50, the correct answer is K. And this actually is another one that gives me more difficulty than most. This is one of the trickier geometry problems. And the fundamental thing in solving this is acknowledging that you don't have to keep the drawing they gave you. in the drawing they gave you, everything is pretty. Everything is this beautiful, everything looks the same, all is well. But if we look at the drawing, the only things that we have are that we have these right angles. That's the only thing that we are given to work with. And so if we were to adjust this triangle so that we have a right angle here and here and here, but those two sides are no longer an isosceles triangle, we can have it kind of tilt. Now you can see that they don't really have to be the same. And that's why K is the answer. CE is this length right here, and ED is this length right here. And if we change those so that they're no longer the same, everything else is still true. We still have those right angles to work with. It's just kind of tilting it. And so in order to solve this problem, I literally had to redraw it, because the more I looked at the picture, the more I got confused. And so the ability to just say, okay, if we change it and make these different, is everything still true? And yeah, you can still have those right angles. It just no longer looks as pretty. 51.
What does collinear mean?
Collinear means that they are co, meaning cooperative or shared. Collinear means they're all on the same line. And that you can see that from the drawing, but they just stay all in the same line.
And it doesn't mean they're equal.
It does not mean they're equal. Bisector, midpoint, something like that, that will mean that they're cut into equal. Collinear just means that they're sharing a line. Same way coplanar is that they're in the same flat plane. All right. 51. Honestly, I looked at it and said, okay, yeah, I know that. This is one that I've talked to you before. The answer is D. Remember the shortcut, you can just punch the pieces out. And so you have this L shape. Yeah, bad drawing. But when we're talking about the perimeter, this can be that, and all of a sudden we have 2 and 1, we have 3. This can punch out. It was 4 on the bottom, it's still 4 above. And this would be 3 on the opposite side. We've got a rectangle. 52. This one is a little bit more challenging. How did you tackle this one?
Well, I knew
Okay.
B and A had to stay in the same spot.
Okay, B and A stay in the same spot. I think you're only allowed pencils, otherwise I would be absolutely going at this with colors, so I'm going to show you with colors. So, what is the area of a triangle?
Half base times height.
1/2 base times height. What is height?
Height. The peak to the base.
Yes. Do you remember what's special about it that make it a height? It has to be perpendicular. And so in this case, our perpendicular is going to be here-ish somewhere. If I change C, I need that distance along AB to still be the same distance. And the way we get that same distance is in order to be parallel. It's like a distance sliding along AB, and it's keeping that same distance, so it has to be parallel. And so what is the slope of that line? Well, it's going to be the same slope as AB. And so if you find the slope of AB, that is our slope that is consistent with AB. And the correct answer would be F. So you need to be able to say, okay, this is my height, and then the fact it can slide along this line, and that height should stay the same, therefore it should be following the slope of AB and still be the same slope. And so it's tracing out a parallel line. That one is a very conceptual problem. And frankly, this is the only test I've seen it on. We've gone over it, but the chances of you seeing it, not great, but it is interesting. All right.
No, that's the answer.
53. How did you tackle this one?
Put it in one equation.
That is a valid way to do it. It works. The chances of making a mistake are not 0, but it's a possibility. Answer was D. Did you get it right?
Nope.
So,
No, I'm kidding. I did.
you did?
No.
Oh.
No.
So,
I was actually 100 off.
I would have done a combination of that. This is one of those arithmetic series problems because it's increasing by the same amount each time. And so on his first day, he made 24 calls. So day 1, he made 24 calls and he's increasing by 5 each time. What's he gonna make on day 2? So, I don't love arithmetic series problems. I make mistakes. I turn them into linear equations. If he made 24 calls on day 1, how many calls would he have made on day 0? 19. And so our equation is y equals 5x, because he's making 5 calls more every day, plus 19, plus the 0 number. You can find out how many calls he made on day 20 with a good old linear equation. So we still have to add these up. You could still do it with the calculator. It starts getting a little bit less confusing. You just have to write down day 1 through day 20 and add them up.
No,
But you can also use that arithmetic series sum. And the idea is, day 1, he made 24 calls. How much did he make on day 20? Using our formula, how many did...
119.
119. And so 124 plus 118 equals
143.
143. So we take 143 divided by 2 is the average, and then we multiply it by the 20 days. And that's where we would get it. So, probably the toughest arithmetic series question I've seen in a while. We have to be able to figure out, well, what is the number of 20 days, and then be able to use that sum idea that if you can find the average of the first and last and then multiply it, it works out to be the same piece every single time. All right, 54. My gut instinct says that this one was easier for you. I'm really hoping that that felt like, oh, okay, I do know how to do math. I like this breather problem. And they throw those in, it helps. So, what answer did you have?
Okay.
And it was correct. 54 was K.
How the heck did you get that? I didn't.
Amen. That's my verdict.
Followed by 55, which again goes back into the stats and probability, goes back into combinatorics, and goes back into, I learned this once upon a time, but I don't remember because nobody reviews it enough. So let's talk about 55, and then we are done. They haven't left yet, so we'll shove it in real quick. So the question is, which of the following expressions of a number gives the number of permutations of 15 objects taken 5 at a time? So we have 15 objects, 5 at a time. And I will admit, this one I am not confident about. I am looking at the answers too. I have not practiced. So, just talk about the permutation of 15 objects if we had them. So that is our number 15 factorial. That's how many it would be if we just had 15 objects, how many different combinations. Clearly that's too many. If we were just doing 15 objects, take 5, that's when we would divide by I'm not explaining this well. Well, I'll give you the answer anyway. We're going to be taking this number 15 and subtracting how many we're picking, and it's also that factorial.
Algebra 2, bro.
I know,
When is the 5 factorial on the bottom? What is
That is the combinatorics. That is combinations. If you were just picking 5 objects and the order didn't matter, you're just talking about this is the group of 5 objects, this is the group of 5 objects.
I think she means it when it is.
That's when we would have the 5 factorial.
Yeah.
And that's the number of combinations of 5 different objects. This one, 5 objects taken 5 at a time. It's erasing this bit because now you're picking 5 objects and the order matters. And so if you pick A, B, C, D, E, that's different than E first, A, B, C, D. And so that's why it takes away the R factorial in the bottom, because now that order does matter. All right. We didn't get to nearly as much geometry as I thought. That took longer than I thought. It was still a good day. Hopefully something made it easier.